Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question. Question number 17 of 2014 NEET physics paper. Students, let us solve the next question, that is question number 17. A monoatomic gas. So it is monoatomic gas at a pressure P having a volume V expands isothermally. So it is a case of isothermal expansion. The first one is the isothermal expansion to a volume V2, 2V. So initially if the pressure is P, volume is V, it changes to, at a pressure P having a volume V. So this is undergoing expansion to volume 2V, and pressure is how much, that we have to find out. That is suppose P2. This is P1, this is V1, this is P2, this is V2. The volume becomes double, then pressure will be what? Because it's an isothermal process, so from here I can write that PV is constant. Isothermal process, PV constant, so P1 V1 is P2 V2. We are interested in P2. P1 V1 is PV. P2 V2 is P2 and V2 is 2V. So from here V cancels out and P by 2, P2 is P by 2. So from here I am getting P2 is P by 2. So volume is double, so pressure has to be halved so that PV is constant. Next, then adiabatically to a volume 16V. Then it expands to adiabatically, that is undergoing adiabatic expansion. So it's isothermal expansion, then adiabatic expansion from here. From here to here, isothermal expansion. From here to here, I'll say it is adiabatic. It is adiabatic expansion. Here the volume was V, here the volume was 2V. Here the volume is 16V. The volume is 16V. So PV diagram, if I think of PV diagram, then this is pressure, this is volume. Then it might be somewhere here also. It's not exactly touching this line, actually it's somewhere here. Anyway. Now for adiabatic expansion, you're using the equation PV raised to gamma is constant. This is the equation I'm going to use. So from here to here, I have to note down the pressure and volume there. The pressure there is P by 2, volume here is 2V. The pressure here I don't know, that is P3, and volume is 16V. I'll use this equation again. That is, suppose that this is P2 V2, this is P3 V3. So write P2 V2 raised to gamma is P3 V3 raised to gamma. Gamma is adiabatic constant. It's a ratio of two specific heats, Cp over Cv, and that is 5/3 for a monoatomic gas. Because the gas that is given is monoatomic, I'll write that this is 5/3. Because it has got 3 degrees of freedom, so it has got 3 degrees of freedom, so 1 plus 2 by 3, so it is 5 by 3. This is the number of degrees of freedom. Now P2 V2 is this one. I'll write P by 2 and V2 is 2V to the power gamma, and P3 I want P3, that is the final pressure. The question is to find the final pressure of the gas and take gamma is this. That means you want this pressure. P3, V3, V3 is 16V, 16V to the power gamma. We want to P3, so I'll rearrange that. I'll have P3 equals to P by 2, 2V raised to gamma, 16V raised to gamma. This is the situation, just I rearrange the situation, and from here I'm getting P by 2. This is actually, we will cancel 1 by 8 to the power gamma, P by 2, 1 by 8 to the power 5 over 3, and this is actually 2 over 3, so this is 2 to the power 3 to the power 5 over 3. This becomes P by 2, and this is 1 divided by 2 to the power 3 to the power 5 by 3, that is 2 to the power 5. So this is P divided by 2 to the power 5, 64. P divided by 64. So the final answer is P3, the final pressure will be 1 by 64 times the initial pressure. So therefore, option number 3 is the correct answer to this question. So it is the option number 3 which is correct. So basically it's a very simple question consisting of one isothermal expansion, one adiabatic expansion, and the pressure volume. In the first case, the certain pressure and volume changing to certain volume, so pressure is found. Then from that that pressure and volume, we are switching to another volume, and then we have to find the pressure. And this is for monoatomic gas. So that is the answer to this question. Okay, thank you.